Hello guys, this is Ganesh Reddy and I welcome you to the Knowledge Treasure Hub. So in the last class we have seen KCL and KVL, Kirchhoff current law and Kirchhoff voltage law, and several problems based on that one. So today we are going to see a little bit complex problems in KVL and KCL. So which means it is a combination of both KCL and KVL. So it is an important type problems. So in our university examination also these type of problems only given, right? We will see an example. So let me to take an voltage source 20 volts. So this is a 20 volt voltage source. So this is a 2 ohms, 2 ohms, 4 ohms. So R1, R2, R3. So here the question is find out the current through this 4 ohm resistor. So this current we need to find out. So let me to take this as I, this as I1, this as I2. So we need to find out the current I2, right? So this is a problem which consists both KVL and KCL. So initially let me to apply KCL at this node. So KCL, what does KCL states? The sum of the current entering and leaving across any node rejection will be equal to 0. So which means the entering, sum of entering currents is equal to sum of leaving currents. So here I is entering current, leaving currents are I1 plus I2. So this is number equation 1, right? So this is applying KVL, case 1. Case 1 apply KCL. Case 1 apply KCL at this node. So sum of the entering currents is equal to sum of leaving currents. I is equal to I1 plus I2. So our problem is to find out the current through 4 ohm resistor, that is I2. Now let me to apply KVL in case 2. Apply KVL. So initially let us apply KVL across this loop. Apply KVL across this loop. So applying, so KVL voltage, sum of voltage rise is equal to sum of voltage drop. So voltage rise 20 volts is equal to, so 2 into R1, sorry, so 2 into I, so R1 is 2 volts, 2 ohms, so 2 into I plus 2 into I1. So R2 is 2 ohms, R1 is also 2 ohms, so 2 into I plus 2 into I1. So that is equal to 20. So let us consider this as equation number 2. So initially we applied KCL at this node. So I is equal to I1 plus I2. So later, so we are applying KVL across the first path. So let us name it as A, B, C, D, E, F. So here we are applying KVL across A, B, E, F, A. A, B, E, F, A. So applied KVL across A, B, E, F, A. So in the third case we are applying KVL across the second loop B, C, D, E, B. B, C, D, E, B. So apply KVL. So across this. So this is a rising current. So this is dropping current. So that is equal to V rise is equal to V drop 4 into I2 is equal to 2 into I1. So this is equation number 3. So we applied KCL, applied KVL at first loop, applied KVL at second loop. So 4I2 is equal to 2 into I1. 4I2 is equal to 2 into I1. So from the equation number 1, we have I2 is equal to I minus I1. I2 is equal to I minus I1. So let us consider this as equation number 4. So substitute this I2 here. We are going to get 4 into I minus I1 is equal to 2 into I1. So therefore 4I minus 4I1 is equal to 2I1. So 4I is equal to, so 4 plus 2, 6I1. So 2 2s are 2 3s are. So therefore 2I is equal to 3I1. Let us consider it as equation number 5. So now substitute this equation number 5 in this equation number 2. So 5 and 2 implies, so 20 is equal to 2I. Instead of 2I, we are substituting 3I1 plus 2I1. So which is equal to 5I1. So 5 ones are, 5 fours are, therefore I1 is equal to 4. So substituted equation number 5 in equation number 2. So 20 instead of 2I, we are substituting 3I1. So 3I1 plus 2I1. So 5I1, 5I1 is equal to 20. So 5 ones are, 5 fours are. So therefore I1 is equal to 4 amperes. So but we need to find out I2. So from equation number 3, we have 4I2 is equal to 2I1. So therefore 4I2 is equal to 2 into I1, 4. So 4 ones are 4 cancel. So I2 is equal to 2 amperes. So this is our solution. So I2 is equal to 2 amperes. So that is our final solution. So it is a simple problem, but in this problem we are applying both KCL and KVL. This is an important type problems which are going to be asked generally in our university examination also. So in this problem, so initially we applied KCL at this node B. So I entering is equal to I leaving from KCL. So here I is entering current, I1, I2 are leaving currents. Therefore I is equal to I1 plus I2. So that is equation number 1. So next we applied KVL across this first loop. So A, B, E, F, A. So sum of V rise is equal to sum of V drop. So here 20 volt is V rise. So next this 2I, next 2I1 are V drop. So 20 is equal to 2I plus 2I1. So that is equation number 2. So next we applied KVL across this second path B, C, D, E, B. So here current is in this direction, here also in this direction, but we are applying KVL in this direction. So this is a positive, this is entering in negative, this is entering in positive. So we considering this as V rise. So since it is entering in negative, this as V drop. So 4I2 is equal to 2I1. So that is equation number 3. So from equation number 1 we have I2 is equal to I minus I1. Substitute this equation number 4 in equation number 3. So 4 into I minus I1 is equal to 2I1. So 4I minus 4I1 is equal to 2I1. So from that we have, so 2I is equal to 3I1. So let us name it as equation number 5. So now substitute this equation number 5 in equation number 2. So 20 is equal to 3I1 plus 2I1, that is equal to 5I1. So we got I1 as 4 amperes. So we have from equation number 3, 4I2 is equal to 2I1. So substituting I1 that in that equation, so we got I2 as 2 amperes. So that is our final solution. So these type of problems are very important. So solve number of problems. If you have any doubt, so please mention it in comment section. So I will try to help you. So thank you for watching. Stay tuned. So in subsequent lectures, we are going to see a number of types of problems which are going to be asked in our university examinations and also in competitive exams. Stay tuned. Thank you for watching.